So in this aspect, we're looking at circle, okay? So here we have the three different diagrams explaining the different parts of the circle. So we have the diameter, which is the line that passes through the center of the circle and divide the circle into two equal halves or two semicircles. Exactly, so the diameter. Then we also have a chord which is a line that passes through the circle but not the center, and divide the circle into two unequal parts. So that's the chord. Then we have the radius, okay, and radius is this line drawn from the point to any part or any point rather on the circumference, okay. So you draw from the beginning to any point on the circumference. Exactly. So this is your radius. All right. Also take note that diameter, when you divide into two, one part is called the radius, okay? Or the two equal parts that are from here to here, they are called the radii. That's two radius. Exactly. Okay. Or two radii rather. So when you have radius, that's making it two. So the plural of radius is what? Radii. Then we have a chord. Okay. So the chord divides the circle into two unequal halves. Okay. Then this smaller part is called a segment. Exactly. It's called a segment. We call this part the minor. Call it out the minor segment. Okay. Then we call this part what? The major segment. Exactly. The minor segment, the major segment. Okay. So this part we have here to be this is a sector. This is how to represent the sector, how to create a sector. This is a sector. And see the angle sustained at the center. So here it's called the major sector. This is the bigger part. Okay. Major sector. And here it's called what? The minor sector. Exactly. So if you're asked what is a circle, you define a circle as the locus of points that are equidistant from a fixed point. Exactly. The locus of points that are equidistant from a fixed point. That's the circle. Exactly to you. Alright, so what's the essence of knowing this is because of when you're given questions in words and you're asked to interpret the question and solve. So you need to know which one is the diameter, which one is the chord, which one is the radius, which one is the sector, the minor sector, which one is the major sector as well. Okay, then we have what we call an arc. Exactly, an arc. Okay, an arc. So what's the arc? From here to here like this, from A to B, is called the minor what? The minor arc. Why? Like this bigger part of the circle. Okay, this line that bounds the bigger part of the circle. Exactly, is called the major arc. It's something that applies to this from here to here. Okay, this is not an arc rather. This is not an arc. This is a segment. So here we have an arc. Okay, what forms the arc? It is a sector that forms the arc. Okay, all right. Then how to calculate for the area of a circle? That's very, very easy. Okay, so the area of a circle from your elementary, we have pi r what? Square. Then if you ask the circumference of the circle or the perimeter of the circle, that's the circumference of the circle, okay, is equals to 2 pi r. Exactly. Alright, so these are actually basic. Okay. Now, you might be asked to calculate area of shaded portion. The area of a shaded portion. Okay. So I'm going to be listing out the formulas you will need in this aspect. Alright. So let's see. The area of shaded portion. Okay. So let's start with the area of the circle. I'm putting that by r squared perimeter. Perimeter of the circle simply means the distance round. Okay, the distance, the boundaries, like the circumference. Okay, that's 2 pi r. Then let's look at the formula for the different part of the circle. So we're going to start with an arc. So the length of this arc. Okay, so I'm going to draw this, draw this, draw this. Okay. So we have A, we have B. So the length of this arc is called what? It's called the minor arc. Okay, the minor arc. So the formula is length of minor arc is equals to theta over 360. Where's the theta? That's the angle sub 10 at the center here. Okay, theta over 360 times what? Times 2 pi r. Alright, pi is always given 3.142 in decimal or 2/7 fraction. Then we have the radius will be given. Okay, so that's the length of the minor arc. How about the length of the major arc? If you are given a question and asked to find the length of the major arc, so we have length, okay, of major arc is actually, now it's going to be, since we have this boundary that's everything like this to be the circumference of the circle, okay, and the formula to calculate the circumference of the circle is what? 2 pi r. So you are now asked to calculate what? Calculate the length of the major arc. So it's going to be the circumference of the whole circle minus the length of the minor arc. So you just subtract the length of the minor arc out of what? Whole circumference. So you now to get what? To get the length of the major arc. So it's going to be what? So it's going to be 2 pi r, okay, minus theta over 360 times 2 pi r. So if you factorize, you're going to get 2 pi r in bracket 1, okay, minus theta over 360. So we call this the formula for what? For the length of the major arc. Is that clear? Alright, the next one is a sector. A sector. So this is a sector. Is that clear? So if you are asked to calculate the area of a sector, this is a sector, this is just an arc, okay? Is that clear? From here to here is a radius, from here to here is what? A radius. So this is an arc. Then asked to calculate what? Calculate the area of the sector. Is that clear? What do you do? So you have area of the sector is equal to, so what do we have here? We have there will be theta over 360 times pi r squared. This is how to calculate, this formula to calculate what? Calculate the area of a sector. Is that clear? Now, this formula is for the minor sector, okay? Now we still have the major sector, that's this aspect, the major sector. So, if you ask to calculate the area for the area of the major sector, so area of the major sector is equals to pi r squared, okay, minus theta over 360 times pi what? Pi r squared. So when you bring out your factorize, you're going to have pi r squared in bracket 1 minus theta over 360. So this is the formula to calculate the what? The area of the major sector. Okay. So the next aspect to what is to know how to calculate that of segment. Is that clear? That of segment. But before we go to that, let's look at perimeter of a sector, which is also common in your examination, perimeter of a sector. So if you have something like this, is that clear? When you say perimeter, talking about the boundaries. So everything here makes up what? A sector. This is the sector of the circle. So the perimeter will now be the sum of all the sides. Okay. So from here to here is radius. From here to here is radius. And from here to here is what? It's length of an arc. So the perimeter, now you add all the sides together, it will be the perimeter of a sector is equal to, ready? It's equal to, from here to here, what do you have? Radius plus, from here to here is radius plus, from here to here is what? It's radius as well. Radius radius, okay, then plus, can you see? Plus, then the length of an arc. So from here to here, plus from here to here, plus the length of an arc. Is that clear? So that's theta over 360 times what? Times 2 pi r. So the perimeter of the sector is what? Is 2r plus theta over 360 times what? Times 2 pi r. Is that clear? Though you can bring out your, you can factorize that. When you factorize this, okay, so what do you get? You're going to have 2r is equals to 1 plus, then here we have theta pi, or pi theta over what? Over 360. So this is the formula to calculate what? The perimeter of a sector. So 2r, okay, 1 plus this. So when you expand this, you get this expression back. Okay. Alright, so let's look at how to calculate the area of a segment. The area of a segment. I want to take a look at all the formulas we have on the board. The area of a segment. Now remember, I told you that we have a segment in a sector. Okay, so this is a segment. This is a segment. So if we have something like this, we have a chord. So this part, this whole part here. Okay, let me shade it. Shaded part is called the minor segment. The minor segment. Then the unshaded part is called what? It's called the major segment. The major segment. Is that clear? Okay. So how do we calculate for the area of a segment? So the area of the minor segment. Now remember, how do we get that of the minor segment? If I complete this diagram like this, I'll extend it to the center. Okay, extend it to the center like this. I have what? I have a sector now. Okay, a sector now. Where here is radius, and this is a chord. Okay, and remember that here is called the angle sustained at the center. All right. So how do we get the area of the segment? So it's going to be area of minor segment is equal to, okay, so this is what we're going to do now. Everything is a sector, right? Everything is a sector. So just subtract the area of the triangle, okay, the area of the triangle from the area of the whole sector, okay? The area of the triangle, subtract it from the area of the whole sector. So what do we have? So you're going to have, that's theta over 360 times pi r squared minus, then the area of the triangle. Look at the triangle now. It's somewhat like this. So we have theta, we have this. So remember from the previous class, I told you that, previous section, I told you that this, if you have a triangle like this, to calculate the area, you just take the two sides, half times the two sides, then sine the angle in between them. So the area is going to be area is equals to half times, as soon as this one side, maybe side AB, okay, times, or probably this is your A, this is your B, and this is your what? Your C. Okay, this is your angle C. So it's going to be half times A times B sine C. Okay, something like that. So it's going to be half times this times this other side. So half times your radius, then times what? Sine theta. That's what we have in the middle. So we're going to have is equals to that's r squared sine theta over what? Over 2. So this is the area of the triangle in this what? Sector. The area of the triangle in the sector. Okay, so put this formula in this to get the area of the minor segment. So we have r squared sine theta over what? Over 2. So this is the formula to calculate the area of the minor segment. Now, if you want to get the area of the major segment, the area of the what? of the major segments, like the way we've been deriving the formulas here. So area of the major segment, area of the major segment is going to be the area of the circle, okay, the area of the circle minus the area of the minor segment. The area of the circle minus the area of the minor segment. Okay, is that clear? Area of the circle is what? Pi r squared. While area of the minor segment is the formula we have above. Okay, so these are the formulas you need to apply when you are solving any question on sector, segment, length of an arc, and so on. Okay, one more thing is how to calculate the perimeter of a segment. The perimeter of a segment. Okay, so how do we do that? Perimeter of a segment. How do we calculate the perimeter of a segment? I'm going to show you that. Okay, I'm going to show you that. All right, perimeter of a segment. So look at what we have here. We have this. Okay, we have this. Okay, we have this. So this is the segment. We want to get the perimeter. So the perimeter here means the boundary of the segment. Okay. So what bounds the segment we have? We have from here to here, which is what? The length of the chord. Okay, and the length of an arc. I repeat, the length of the chord and the what? The length of an arc. And if you notice, the length of the chord happens to be the base of the triangle. You know, here we have theta, radius, radius. The length of the chord happens to be the base of the triangle. And here is what? The length of the arc. Okay. So the perimeter of the minor segment, the perimeter of the minor segment will now be, okay, yeah. Now how do you get the length of the chord? Okay. To get the length of the chord, this is what we're going to do. You divide this into 2. Okay. Divide this into 2. Alright. So if here is A and here is B, that means the total length here is what? It's AB. Is that clear? So length AB, the side AB, is equal to what? L, to represent length of the chord. Okay? So if side AB is L, to represent that L, that means half of L will now be what? Will be L over what? Over 2. And here will be what? L over 2. Exactly. That's half of L. Then your angle divided into 2, here will be theta over 2. And here will be what? Theta over 2. But you know what? You don't make use of this or this, but I'm going to make use of the theta, which is the familiar, one you're familiar with. So you don't need to divide your length in 2 places again. Okay? So just make use of this now. Okay? Because the angle divided into 2. So we assume that we don't have any value for A. Is that clear? N remains L. So we have the height. Remember we have the height. So what's the height? The height represents what? As H. Is that clear? Represent as what? As H. Okay? So how do we now get the length of the chord? Because if you have the length of this, let me make here M. Let me make here point M, which is the middle of AB. So if I have just the value for this length, definitely we have gotten the what? The value for both sides. Okay? Yeah and yeah. Alright, so how do we do it now? You carry that like this, something like this, you bring it out, you have here to be what? M, here to be what? A, okay, here to be what? H, Alright? Then here what? Going to be the radius. Exactly. Then here we have it to be what? Theta over 2. Can you see now? Theta over 2. Alright. So I want to get here. Can you see now? I'll name it X. Exactly. Though everything is L, Abby, but I name it X. Now this side is facing my X, okay? Then we have your radius. So if you look at it, this side facing this point I'm facing the X is called the opposite. This side is called the opposite, okay? This side is called, this 90 degrees, this side is called the hypotenuse. Exactly. The hypotenuse. Okay? So we're going to make use of the opposite and the hypotenuse. Do you know why? Yes, because we don't have any value for h. You understand? We don't have any value for h, and you don't necessarily need to make use of the h when we have the radius, because we always give you the value for radius. Is that clear? How do we be given the value for h? So make use of the radius and make use of x. Is that clear to you? Alright. So what is your how do we get our x now? Since here is opposite, that the side facing the angle, and here is hypotenuse, so it's going to be this. We're going to have opposite and hypotenuse, which is what? So we have sine theta over 2 is equal to opposite, which is x, over hypotenuse, which is what? R. So make S sort of formula. So x is equals to R times sine, we cross multiply, sine theta over 2. Okay? Alright, so x is equals to R sine theta over 2. Now mind you, I've got our x now. Mind you, the x I place here is half of L. Remember, AB represents what? L. And the x is half of what? The x rather is L over 2. It's half of what? Half of L. This L. So here is x, here is x. Exactly. Half of what? Half of L. So what do we do now? Since x equals R sine theta over 2, and x also equals to what? L over 2. What do? You equate them. Therefore, L over 2 is equals to R sine what? R sine theta over 2. So therefore, we have length of the chord, which is L, that's length, that's side AB, L, is equals to 2R sine theta over 2. So this is the length of the chord, exactly. Okay. So what do we do now? Calculate the perimeter of the minor segment. So length of the chord plus what? Plus length of the arc. Exactly. Alright, so let's go length of the chord plus length of an arc. So it's going to be, let me erase this. So it's going to be, my thing is there, so it's going to be perimeter, this is the last one, perimeter of a minor segment is equal to length of a chord plus length of an arc. Length of an arc. So what is the length of a chord? The length of a chord is 2R sine what? Sine theta over 2 plus what is the length of an arc? The length of an arc is theta over 360 times 2 pi r. 2 pi r. Okay. Alright, so this is how to calculate the perimeter of a minor segment. Exactly. Alright. Perimeter of a minor segment. Okay. So let's look at one or two examples and we move to the next aspect. Exactly. Alright. So we are to solve the question on the sector, segments, and all that was explained earlier. So these are questions on them. So we have to calculate the length of an arc. The question says the figure below is a sector of a circle. Question, once is calculate the length of an arc. 2, the perimeter of the sector. 3, the area of the sector. 4, the area of shaded portion. And 5, the perimeter of the segment. Okay, what segment? The perimeter of this segment, the minor segment. Okay, so when you do it like this, you know that it's the minor segment, because if you are giving the whole circle, the complete circle, so you have to, it will be specified whether it's a minor or major segment. Okay, but since we have a sector, or we're giving a sector of circle, so this is the minor segment. So the first one is to calculate the length of an arc. So just apply the formula. Okay, so the derivations are necessary for you to understand how the formulas was derived or were derived. But the most important thing about it is that you should memorize the formulas and know when to apply them. Okay, so we want to apply the formulas we actually derived. So what do we do here? Calculate the length of an arc. That's the first question. So question 1. Formula for length of an arc. Length of an arc is equals to theta over 360 times 2 pi r. And then we'll be given the value for pi. You might be asked to take what? Take pi is equals to what? Pi is equals to 22 over 7. Okay, that's the constant. So what do we have here? So theta represents the angle. Okay, so it's going to be 60 over 360 times 2 times 22 over 7 times r represents the radius, and the radius is 5 centimeters. Okay, so what do we have from here? So what do we have from here? We divide. So it's going to be 60 divided by 360. Okay, and what we have here is 0. We have the 0 point. Okay, and there's still another way to do it very fast. This also means 2 over 1. This means 5 over 1. Okay, alright, so what do? Multiply everything above, multiply everything below. So 60 times 2 times 22 times 5. 60 times 22 times 5, and you get 13,200. Over, they have 360 times 7. 360 times 1 times 7 times 1. That will give you 2,520. So you divide. So 13,200, okay, divided by 2,520. What do you have? The answer is 5.23 centimeters. So this is the length of the arc. The question 2 says calculate the perimeter of the sector. Okay, the formula for that is the perimeter of the sector is equals to 2 radius, okay, plus theta over 360 times what? 2 pi r. So radius 1 plus the second radius plus the length of what? Of an arc. Is that clear? So what is your radius? 5. It's going to be 2 times 5 plus, if you notice, the theta over 360 times 2 pi r is the value for length of an arc, or the formula for length of an arc. And we have got the value to be what? 5.23 centimeters. So it's going to be 5.23 centimeters. So what is our answer? It's going to be 10 plus 5.23 centimeter. Our answer is what? 15.23 centimeter. Then the next question says that calculate the area of the sector. The formula for that is area of the sector. Area of a sector is equals to theta over 360 times pi r squared. So what's the theta? That's 60. Then we have 360 times. What's your pi? 22 over 7. And what is your radius? The radius is 5 centimeters. That's 5 squared. Okay. Remember the method, multiply everything above, so it will be 60 times 22 times 5 squared, 33,000, 33,000, okay. Then we now have 360 times 7 times 1, we have 2,000, okay, 500 and what? 20. So when you divide, you're going to have your 33,000, okay, divided by 2,520, and you get that the area of the sector will be, 13.09, which is approximately 13.1 centimeter square. Okay. All right. The next aspect is this. Let's look at the next question. Okay. It says calculate the area of the shaded portion. Now, if you look at it now, the shaded portion is a segment, a minor segment. So, the formula for calculating the area of the minor segment, so that's number 4. Minor segment, so we say area of the minor segment, okay, is equal to 1/2 is equal to theta over 360 rather, times pi r squared. Now the area per sector minus the area per triangle 1/2 times r squared sine theta. So what do we have? From here we have, what's the theta? That's 60 degree over 360 times the pi is 22/7 times what's the radius? That's 5 squared minus 1/2 times what's your radius? 5 squared sine 60 degree. Alright, so from here we have this to be. Remember you have to multiply everything. And when you do that, you can see 60 times 22 times what? Times 5 squared. We got 33,000. Okay, over 360 times 7 times 1, which is similar to this. We got 2,520 minus. Then here we have 1/2 times 25 sine 60. So this will give us this value, which is 13.09 minus. So here we have 25 sine 25 sine, okay, 25 sine 60, and you have 21.65 divided by 2, and you have 10.83, okay, so 13.09, okay, 0.09 minus 10.83 minus 10.83, and what do you have? You have 2.26 centimeter square. So this is the value for the area of the minor segment. The last one says calculate the perimeter of the segment. So the perimeter of the segment is the perimeter of the segment is equal to the length of a chord plus the length of an arc. Okay, the length of the chord plus what? Plus the length of an arc. Is that clear? Alright, so what's the length of the chord? That's 2r sine theta over 2, okay, plus the length of an arc, theta over 360, theta over 360, theta over 360 times 2 pi r. Alright, so what is the radius? 5 centimeters, so we have 2 times 5, okay, then sine 60 over 2, that's the angle, plus 60 over 360 times 2 times 22 over 7 times what? Times 5. So here we have 10 sine 30, okay, plus, now this expression here, 60 over 360, okay? We got it from the length of an arc, you can see 60 over 360 times 2 times 2 times 5, and this is it here, okay? And everything here will give us what? We got 5.23 centimeter. Okay, so 10 sine 30 is actually 5 because sine 30 is 0.5. Times 10 as 5, plus 5.23. So what do we have? We have 10.23 centimeter. Okay, so this is answer to the question, the perimeter of the segment, minor segment. Alright, so we've come to the end of this section. I hope you really enjoyed it. Alright, so let's look at other section. Thank you.